Most of the students, when they see this atomic sizing, nuclear questions, they just use the basic multiplication methods, but they forget that the universe does not scale linearly, and neither do the atomic nuclei. So, which, for instance, in this question, what is given to us that this is a silver nucleus, and the silver nucleus radius is, because in the question it is mentioned that the diameter of the silver nucleus is three times the diameter of that unknown element which we have to identify, we have to find out. So I would say that this is that unknown element, and if its radius is r, then it would be 3r according to the question. So its nucleon number is 108. What is a nucleon number of this unknown element? We have to find out. Either it's a helium, lithium, boron, or neon. Let's find out. Now we have to use here the information that we get from the Rutherford scattering experiment, because that make us capable to calculate and estimate value of the radius of nucleus based on the authentic calculations. So we know that the radius of any nucleus is proportional to the one third of the power of nuclear number. That's why I told you in the start that it does not scale linearly, right? So we are going to use this information. We know that the radius of the silver is three times the radius of that unknown nucleus. Now, the radius of the silver can be written as R0, which is Fermi radius, and its value is a constant. It will not be affected. So a nuclear number of the silver raised to power 1 over 3 is equals to 3 times of r0 ax. We don't know the nuclear number raised to power 1 over 3. So we can cancel out this constant on a both sides, and you can turn it into the form of ratio. I mean, you can take this 3 on the other side. Nuclear number of the silver is 108 raised to power 1 over 3 divided by 3 is equals to nuclear number of unknown nucleus raised to power 1 over 3. Now I want to get rid of this 1 over 3. So what if I take the one, I mean the third power on the both sides? If I take a cube on both sides of the equation, get rid of this one third, so it will be like this, right? So I'm going to take, to balance this, I'm going to take cube as well here, right? So it is cancelled out, whereas you can open the bracket and you can take cube in numerator and denominator. So what you will get eventually is 108 raised to power over 3 raised to power 3 is equals to the nuclear number of that unknown radius, and that is 108 over 27, and that is 4. It means that it must be according to Rutherford's estimated radius equation, it must be helium, which means the option A is the right answer. Now see that although the silver have a higher nuclear number, it have a larger number of protons and neutrons in its nucleus, but the helium is relatively very lighter. But you can see that their radiuses are in this format, that the radius of silver is three times of the radius of helium, but there's a huge difference in their masses. So the right answer is option A.